All right. So just with this last one here, if we're looking at it, we're seeing, Merlin, Riley, we're seeing that arrow go down forever and across forever, and the same, up and to the right forever. So there's no constraints on its domain and on its range. So when we have no constraints, so let's start with the domain. The domain is represented by the variable x, and what we write is x, and then we do an epsilon, which is like a capital E, but it has a curve instead. That's a Greek letter. And this means belongs to. Okay, that's what it technically means. Okay, and so all we're going to say is x belongs to the set of all real numbers. That means any number from minus infinity to positive infinity. All right, so when it can occupy any value for x, we write xer, and for range, we write y. Y belongs to the set of any real numbers. Okay, so if there's no constraint, that's some interval and set notation that we need to know. Xer, Yer. Okay, now I just needed to fill in the graph we can flick back to our examples now. We've got two examples here. And we were looking at these graphs in exercise 1C and D, these reciprocal function graphs. And if we're going to think about the domain and range, you might think, okay, for domain, well, it keeps going to the left forever, and it keeps going to the right forever. So you might think, oh, well, let's write xer. But x cannot be any real number. In fact, there is one number that x cannot be on this graph. What's the number that x cannot be on this graph? It can be 0. It's 0 there. Oh, sorry, x is 0 there. The y value is 0 there. It's -3, isn't it? All right. If you look at the x values, what these asymptotes mean is that the blue line is getting really, really close to the asymptote at -3, but never touches it. And then the same in this direction. It's getting really, really close to that asymptote, but never touches it. An asymptote's a line that it gets infinitely close to, but it doesn't matter how far that way you go, it's never going to reach it. So for this function, it exists to the left forever, to the right forever, but it doesn't exist when x is -3. So we don't write xer, we write x does not equal -3. And the way we write does not equal is just an equal with a line through it. X does not equal -3. Okay, so let's use that skill to answer the range then. All right, so we can see the arrows going down forever. It's going up forever. So you'd be tempted to write yer, but there's a value of y, that should say y, there's a value of y that it doesn't exist for. All right, as it's coming down here, it's getting really, really close to 2. And as it's coming up here, it's getting really, really close to 2, but it never reaches y is 2. So we're going to write the range y does not equal 2. Y exists for every value except 2. All right, this was our next example. Okay, so when we think about the domain, all right, domain, we go from the left to the right. Now the point furthest to the left, it's going to the left to infinity. It's going to the right to infinity. There's no asymptotes. So for this one, x belongs to the set of all real numbers. X can be any number from -infinity to positive infinity. All right, and then for range, we go, what's the lowest value of y? The point closest to the bottom. We have y is -2. All right, and I'll still make the argument the way that I've taught you to do it. The lowest value of y is -2. The highest value of y is infinity. We drop the infinity, and then we place the variable first by flipping the inequality. The y value is larger than or equal to -2. The domain, any real value of x. Okay, on to our last example here. We have an asymptote at y equals 2. All right, let's do the domain first. We can see it goes to the left forever and to the right forever. There's no asymptote restricting the value of x. There is an asymptote. We call this a horizontal asymptote. It does restrict the value of y, doesn't it? Now what we can see here is this arrow says it's going that way forever, and it's approaching the asymptote. So it's getting really, really close to 2, but it's never going to reach it. All right? So the lowest value of y is 2, and it doesn't reach it, so we don't include it. It doesn't reach it because it's an asymptote. The function does not exist below this asymptote. It only exists above it, which means the lowest value of y is going to be 2, but it doesn't equal 2. It gets infinitely close to 2 as we're moving to the left. And as we go to the right, it's just going up forever. So we'll put 2 to infinity. We drop the infinity, and then we write the variable first. Y is larger than 2. Okay, the y values is going to be larger than 2. All right. Any questions about those three? Okay, so I just wanted to say you can see why we break this skill down. Like if we jump straight to here and we start trying to use all of the notation at the same time, it's very complex. So it's good to do it step by step by step. We're now ready, now that we've used these supplementary resources, we're now ready to access the questions in the textbook. And we should be able to do up to at least question 3. We may need to come back